This is a short video showing how to select, copy, and paste a text data table into working Python source code using the EMACS code and text editor. And this video uses a function which is added to EMACS in my .emacs startup file and is bound to control =. To do this very quickly and efficiently, it's not something you can do with vanilla EMACS. I've shown in a previous video how to do it in vanilla EMACS, but that is somewhat cumbersome and time consuming, and this just automates the process. So let me quickly show what I'm talking about. So here I have a text table. This could come from an email that you received. It could be something you cut and pasted from a website, a PDF document, various sources. And it contains various text, and it also has text over here along the side that you don't want. All you're interested in is these columns of data, which are separated by spaces. So what we want to do ideally is not select it like this, which selects the text we don't want. We want to select it rectangularly, which we can do in a number of ways that are shown here automatically in any version, modern version of EMACS. So what I'm going to do is type Control-X space, which is the built-in hotkey to the rectangle mode. See here I'm selecting rectangles. So I can go over here and select just this table. Then I hit Escape key, W, and the Escape key is located in the upper left corner of my keyboard. That's very typical of Windows keyboards, most keyboards. So I now have this, just the data table in the kill ring is what they call it in EMACS, but basically in the EMACS clipboard. So let's go over to some Python code. Now the problem is that tables are often in this space delimited format that I just showed in ordinary documents, but Python can't easily read those. This is Python code, and it's code to plot the data. So what I can do is I will now hit Control-Y for yank. Sorry. It wrote over some stuff, so I'll undo it. This is one of the problems with the rectangle paste. So we want to make a big room where we can paste the rectangle. If we don't do that, the rectangle will actually go over this code as you saw, which you don't want to have happen. So we'll go up here, and again, we'll hit Control-Y for yank, and here's the data we want to analyze. So the next thing that we want to do is select that. We don't actually have to do the rectangle select. And now I'm going to press on my EMACS. This is not standard EMACS. Control =. So notice what happened. The data is still the same, but it's been put in the form of Python code. So np.array converts this list of lists in Python terminology to a fast numerical array, what we can do fast analysis on. We can do graphics with it. We can do statistical analysis. We can fit models like lines, for example, to this data. The open bracket starts a list. Each row of the data table has been turned into a list. So open bracket 0.5, 276 is the first row, close bracket. And then each row is an element in a larger list. And now we want to make it has this default name, so you're supposed to put the correct name here. This is my code, and we'll just tighten it up a little bit here. There we go. So notice what we're doing. The data is now in table when we run the code, and we will then plot that data here. Okay, how can we do that from within EMACS? You could do this from your console command or in various ways. You type Python _table.py. Actually looks like I may not have saved this. Let's make sure that's been done. Yeah. Okay, I want to make sure the new code is saved. So the stars disappeared here. So now we're going to run that code with our Python interpreter. And this is the actual data. Now this is very simple. I just plot it, but I could fit a model to this. For example, the bell curve, the normal distribution, the Gaussian is a possibility. This could also be similar to various other less well-known distributions. That's in a nutshell what's going on here. Let me go back to the code. So remember, what I did is I basically took a table and was quickly able to transform it into working Python code. Let me show the .emacs file where I set this up. Okay, so let me go over what we have here. So I have a key. This is a command. In the .emacs is the file Emacs loads right when it starts up. Let me just, for clarity, show the version of Emacs. Okay, so I have EMACS 27.1. I'm on a Windows 10 computer. Let's go back to the .emacs file. So I bind this key sequence, control equal sign, which on my Emacs doesn't do anything, to a function I created called Python table. What Python table does, as is explained here, is it takes whatever region you selected in Emacs, copies that text into this temp variable. Then it runs table rows on that temp variable to turn them into valid Python code. And then it shows me in the progress message what happened. It deletes the selected text and inserts the new actual Python code, which is something done with Python table rows. What does Python table rows do? That's this function here. So this does the actual guts of transforming the code itself, or actually the data table itself is turned into Python code. So the data table would come in, the actual text in input string. We start by generating the code for table name equals NP array. That's the header. And then we apply regular expression matching and replacing in order to transform the comma, the 1,000 separators, into underscore, which is actually 1,000 separator in Python. Then we bracket each row in open square bracket, the row, close square bracket, comma. So that's a Python list. The third step is to take the spaces and convert more than one spaces, like 5 spaces or 8 spaces, to comma, and I'm sorry, it's doing it here, to comma and a space. So this is any number of spaces between the columns is transformed regularly into just a comma and one space. And then we add the tail is just to close the list of lists, and the close paren is to close the np.array, which converts it to these fast numerical arrays. So we're building the code, and we use concatenating in Emacs Lisp to build the entire code. So what this is going to return is a valid block of code. So what it returns is this code that we see here. Right? So this is generated by the Emacs Lisp code. All that happens when we hit control equal sign, and I will include a pointer to the actual code in the show notes. So let me just go over that one more time, kind of repeat the process. All right. So what we do, and let me actually, let me just do Control X space. So we're going to select the table. We do this. Now we hit Escape W to copy it. So now we have the table in the actually in the buffer in the clipboard, the equivalent of a clipboard for Emacs. We go to our Python code. We already have this here, but let's just do it again. And what we're going to do here is, oh, no, I did this again. Again, this is something. All right, let's make room to paste the table. So right now it's a space delimited table, and it would cause an error in Python. Python would not be able to process this. So we select it, we'd hit control equal sign. Now we have viable code, and let's say that we call this table name 2, just for fun. And what we're going to do is change code down here, table name 2, and we're going to do the same here, table name 2. So it should plot, and we could even put this here, table name 2. Okay, so this is code to plot that data, and we have actually done it again. Save. Again, we've used this function Python table, which is bound to control equal sign, to generate this code very quickly, and then we do this. So let me show this again. Again, we'll go to shell. We'll come in here and we'll do Python table.py. We'll just double check it is saved. We don't see the stars. We hit return, and there we are. And this is in fact the same data again. Notice table underscore name is in the title. So again, it's the right data. And let me go back to Python table.py. Sorry, that's not what I want. Python table demo. Okay, we'll go back to the text. We'll make this the full view. And that, in a nutshell, is how to do this quickly and efficiently using the Python table function that I created bound, in this case, to control equal sign. In fact, however, you could bind it to whatever keystroke or sequence of keystrokes you like. This concludes this video presentation. If you like this video, please click like. Please click subscribe and the notification bell if you would like to receive more content from us. You can avoid internet censorship by subscribing directly to our RSS news feed. Please consider sharing the link by email and on your website or blog, in addition to liking, upvoting, or sharing on increasingly censored, advertising beholden, big company social media. We have encountered such censorship. Mathematical software is developing algorithms and software to automate data analysis, reducing the risks of costly errors and increasing the predictive power of the results. You can support our work financially by subscribing on our Patreon page, https://www.patreon.com/mathsoft, or scanning the QR code in the lower right corner.